Alright, let's take a look at today's lesson, which is 5.7, interpreting graphs of linear functions. So by now we know what linear functions are. Functions that form a straight line, that also pass the vertical line test. Those are linear functions. And now we're going to take a look at a couple of different properties of these linear functions. So first things first, let's take a look at our information up here. As linear functions have implications in the real world, such as businesses and identifying trends, it is important that we are able to look at linear functions as well as interpret them. So before we can interpret them, we want to define a couple of different items. We want to define what this horizontal intercept is, and we want to define what this vertical intercept is. So horizontal intercept is going to be the point where the graph touches the x-axis, right? Horizontal means horizontal line touches the x-axis, and the vertical intercept is the point where the graph touches the y-axis. So taking a look at our example here is a graph of a scenario where the height of a float plane is graphed against the time. So the horizontal intercept on this graph is going to be the point where this graph touches the x-axis. If I take a look along, the graph is touching the x-axis right here. So as a result, we say that the horizontal intercept is the point 10. And as a coordinate, that 10 basically means that's the point 10, 0. Similarly, the vertical intercept represents the point where the graph touches the y-axis. So in this case, the graph touches the y-axis right here. So the vertical intercept is 1000. And as a coordinate, that would mean the point 0, 1000. Alright, let's take a look at our next example. So the graph shows the fuel consumption of a scooter with a full tank of gas at the beginning of a journey. We want to find the intercepts and give their meaning. What do they mean? So we want to find both the x and the y intercepts. Let's take a look at it. By looking at your graph, what would you say is the horizontal or the x-intercept? So horizontal intercept. Horizontal intercept where the graph touches the x-axis, so that would be right here. So the horizontal intercept is 200 kilometers. Actually, I shouldn't say that. I should just 200. The number is what we're concerned with. And our vertical intercept is the point where the graph touches the y-axis. That's the point 8. I can also write these as coordinates. Horizontal intercept would be 200, 0, and this one would be 0, 8. You'll notice that in the horizontal intercept, the y value is always 0. And similarly, in the vertical intercept, the x value is always 0. So that would kind of be indication of which point we're looking at. We can also look at the graph and define the domain and the range of those graphs. Let's take a look at the domain. We can say with the domain of that graph, the domain of this graph, if you remember from a few lessons ago, what is a domain? Domain corresponds to which values? If you said domain corresponds to x values, you're absolutely correct. So the domain tells us what the x values are. Look at that graph. What are all the different x values that are covered in that graph? And our x values go from 0 all the way until 200. And we're working with distance here. So I'll say the domain represents that your distance is bigger than or equal to 0 and less than or equal to 200. That is the domain. Similarly with the range corresponds to all possible y values. So as a result, all possible y values are those right there. So it goes from 0 all the way to 8. So I'll say the volume, which is V, is bigger than or equal to 0 and less than or equal to 8. Alright, next problem. Sketch a graph of the linear function f of x equals negative 2x plus 7. So we learned how to do this using a table of values. Now, table of values basically take some numbers, plug it in, come up with some y values, plot the points, you get the graph. We're going to try and make our steps a little bit different this time. Instead of making a table of values, picking a whole bunch of points, if you think about it, we really only need 2 points. Any 2 points on a graph, say here and here, will actually make you a linear function, a straight line. So if you think about it, we really only need 2 points to make a graph or make a linear graph. And we're going to use our special 2 points that we've learned about so far, called the y-intercept, which is the vertical intercept, or the x-intercept, the horizontal intercept. So today, when we're graphing these functions, we're simply going to go ahead and find out what the horizontal and vertical intercepts are, and simply use those 2 points to come up with our graph. If you're stuck, you still want to use the table of values, you can, but for now, let's try and do it using this horizontal and vertical intercept pattern. Alright, let's start off with our first problem here, which is graph the function f of x equals negative 2x plus 7. So since the function is a straight line, since the function is linear, we know its graph is a straight line. Okay, so we're going to find out by first finding the horizontal intercept, the x-intercept. Actually, we'll first find the y-intercept. It's a little bit easier to do. So first things first, determine the y-intercept. That's just another name for vertical intercept. Now, one of the things you will have noticed in the previous example here, when you're looking at this intercept, when we had a vertical intercept of 8, what did you notice about the x value here? You will have noticed that the x value is 0. So our vertical intercept happens when the x value is 0. I'll use the same idea here. My vertical intercept is going to happen when x becomes 0. So as a result, I will get the following equation. F of 0 equals negative 2 times 0 plus a 7, which is negative 2 times 0 is 0 plus a 7, which is simply 7. So as a result, my vertical intercept ends up being the point 0, 7. So as a result, on the graph, I will have the point 0, 7. 0, 1, 2, 3, 4, 5, 6, 7. Here's the point 0, 7. Similarly, the second thing I need to do is determine the horizontal intercept or the x-intercept. Determine the x-intercept. Just another name for horizontal intercept. Use abbreviation there. And again, if I go back and take a look at my example in the previous example, you'll notice that horizontal intercept happens when the y value is 0. Right? So horizontal intercept happened at 200, 0. So there the y value was 0. Similarly here, horizontal intercept happened when the y value was 0. So we'll use that idea and we'll sort of work backwards. We'll say, if I know that when the y value is 0, I'll have an x-intercept, I can plug in y equals 0, figure out what's the x value where the y-intercept happens. Or actually I should say when f of x equals 0, because f of x is the same as the y value. So let me plug that in. So in this equation, when I plug in f of x equals 0, I'll get the following statement. 0 equals negative 2x plus 7. Let's do a little bit of algebra. Subtract 7. Subtract 7. You're going to get negative 7 equals 2x. You want to isolate the x by itself. We divide both sides by 2. Divide by 2. You're going to get x equals negative 3.5. So as a result, your x-intercept is negative 3.5, comma 0. That's your x-intercept. So on a graph, that's going to end up right here. So negative 3.5, comma 0, 1, 2, 3.5, comma 0. Oops, we don't need that. 3.5, comma 0. And then your resulting graph is simply going to be the straight line that's formed by plugging in those points together. Oh, I made a mistake here, didn't I? It's supposed to be negative 2x. I'll put a negative here. It's supposed to be dividing both sides by a negative 2. In fact, it's supposed to be a positive 3.5, comma 0. Good thing we caught that in time. Positive 3.5, comma 0. So 1, 2, 3.5, comma 0 right there. Okay, draw a straight line. Make sure you extend that straight line. We want to make sure that our graph is fully extended. We're not just limiting it down to those 2 points. And when all is said and done, that's the graph you're going to end up with. Again, similar to what we did last lesson, except this time we're not making a whole bunch of table of values. We're only using these 2 special points, your horizontal intercept and your vertical intercept. Alright? And I'll quickly label this point as well, which was 3.5, comma 0. Okay, so that hopefully makes sense to you. Let's take a look at our next example, which is right here. Which graph has a rate of change of a half and a vertical intercept of 6? So now we need to first of all examine both graphs and see which one of them has that rate of change. Now because the rate of change is positive, right, chances are the graph is going to be increasing from left to right. So because the rate of change is positive, graph should be increasing from left to right. And then y-intercept of 6. So I just need to examine these 2 graphs and see which one satisfies the criteria that's given to me. And by looking at those graphs, I can say the one that's increasing from left to right is right here. This one's also got a y-intercept of 6. And it's increasing from left to right, so it's got to be option B. Even though this one's got a y-intercept of 6 as well, this one is decreasing from left to right, so the rate of change is going to be a negative number. Now, however, if that wasn't the case, I'm just telling you that the rate of change needs to be increasing from left to right. But if we don't know that already, we can also actually calculate the rate of change and see if that satisfies our criteria. If I want to calculate the rate of change on the first graph here, right, rate of change is going to be pick any 2 points, see what the vertical distance divided by the horizontal distance is. So say I want to pick these 2 points over here, this one and that one. You notice that the rate of change, the vertical change is -2, horizontal change is +4. So rate of change is -2 divided by +4, which becomes a -1/2. Whereas on this one, if you pick 2 points, say I pick this point and this point again, the vertical change is +2 and the horizontal change is +4. So here the rate of change will be +2 divided by +4, which is +1/2. Right, so that's where the +1/2 comes from, because you needed that to be a +1/2. So we can also